All right, welcome back. So now let's go and talk about the notes here for the polar equations. And again, the first thing is just to really understand what is a polar coordinate on a polar graph. So this is a XY axis and a polar graph. All right, now, so we have the original X and Y, right? And typically if we were going to plot a point X or an XY coordinates, what we do is just measure the distance, horizontally away from the origin, right? And then vertically away from the origin. And we'd create a nice little coordinate point here like this, right? And this would be what we call XY, okay? So that is what we call our rectangular, and that is what we are familiar with basically up to this point, okay? So now when we're looking at this in terms of these circles, what we can recognize is, yeah, that's still like a horizontal distance 1 and a vertical distance 1. And if you make a circle, right, we know that's the unit circle anyways, but you can see any point that lies on that circle is going to be a distance of 1 away from the origin. Now, instead of calling it an origin, we're going to call it a pole. So this is going to be now our pole, and these circles represent the distance away from the pole. And then the other thing we want to look into is also not only do we have a distance, right? So we have a distance here of 1, 2, 3, 4, which we call our R. All right, that's going to be our directed distance away from the pole. And we'll talk more about direction as we get into the process video and seeing how that applies. But then we're also talking about the angle. And if you remember, like this is in our standard form, we can measure the rotation of this angle, how far it is away from our positive x-axis. And that is going to represent our angle theta, right? So we can take the same coordinate point xy, which is a horizontal and vertical distance away from the origin, and we can represent that by a directed distance away from the pole, as well as an angle in standard form, which we call r comma theta. So that is what we call our polar point. So it's going to be important to make sure we understand graphically how our polar points are created in connection as well as in difference with the rectangular coordinates. Now, the next thing we're going to want to do is look at how to relate polar and rectangle equations to one another. And to do that, we're just going to go back into trigonometry and understand again, like what is the relationships here with our trig and a coordinate point. So let's say we have a coordinate point here, x comma y. All right. Now, if you remember in our trigonometry, if we had a coordinate point xy, we can create a right triangle from this, right? Because x represents the horizontal distance away from the x-axis and y represents the vertical distance. So if we drew a direct line here, now again, we called that line r, and then we said this was going to be x and this was y. And one of our first definitions that we came for the sine function, once we got out of like SOHCAHTOA, the opposite over hypotenuse, once we put that triangle on a coordinate grid, we said the sine of an angle, right? So let's put that angle theta here, was equal to y over r. Now, again, if you look at this relationship here, y equals r times sine of theta, all we need to do then is just solve for y. So if we multiply by an r on both sides, we get y equals r sine of theta. So it's the same relationship that we already remember. Like we already know sine of theta is opposite over hypotenuse. It's just that it's just now solving it for y. And we can do the same thing for cosine, right? Because cosine of theta would equal x over r. So if you multiply again by r on both sides, you get x equals r cosine of theta. So you can see how that relationship works between the x and the y coordinates as well as our r and our theta, right? Our rectangular and polar points are represented here on this triangle in this coordinate grid. Now, the other relationships, again, come from the triangle, right? We also know that looking at this triangle, that the tangent of theta is opposite over hypotenuse, y over x. And then here, we just recognize that to be the Pythagorean theorem. So we could say x squared plus y squared equals r squared. And there you go, ladies and gentlemen. That is our notes here for our polar equations. Now it is time to go ahead and get started into actually applying, being able to graph polar points, as well as converting between polar points, rectangular equations, and polar equations. I'll see you in the next video. Cheers.